We're going to be talking about PRTG, how we use it here, how it's used for us at L7. Oh, God. Okay. So PRTG, what does it do? Everybody's aware pretty much now what PRTG is, but I'll explain it for anybody who's not. PRTG is our monitoring system and alerting system. Monitoring is looking to see if things are wrong or looking at things. No questions already, Chris. Come on. Alerting is actually producing something that tells somebody what it is or what's going on. So remember that those are key concepts in actually every monitoring system. Monitoring is not necessarily alerting because there are some cases where we monitor things where we don't alert on them. Today our standard is to monitor firewalls, routers, anything on that edge network. Very, very soon, and actually we already have a couple of things in production, we're going to be monitoring ESX servers for things like hardware failures, data store free space, and up or down. What else is on here is it's a web-based solution for guys that are using it from the console. When you guys log in, everybody gets their own login. Some customers have access to their group within it, so keep that in mind. You know, it's one of the better reasons why it's critical that you keep everything nice and neat, and that you're using our naming conventions for devices and sensors. And actually, that brings me to the final point on this slide. It is absolutely critical that you guys pay very close attention to our standards on naming sensors. People use these alerts, which is how where the names come into play, for critical outages. These are not for, you know, my printer is broken. This is for a server is down. And those naming conventions have specific information in them, and they need to be set up in such a certain way to make the execution on those alerts as fast as humanly possible. So you need to pay as close attention to detail as you can in following our deployment docs. You know, I can't stand to see what I just saw yesterday, which is a sensor under wholesale carrier services. It's called Samsung UBGate. That's great, but I don't know what that is. That doesn't help anybody. You know, you go to the location tab and there's nothing in there about it. And if somebody gets that and it's a critical outage and it's 2 o'clock in the morning, they're going to be pissed at whoever created it. Moving right along. Key concepts of PRTG. You got the remote probe. Everything, the probe is essentially an agent-based install. It's what receives all the data and reports back to the core PRTG server. Yeah, sorry, I can't. This is unlicensed for some reason, and it doesn't have the ability to, well, maybe it does. Let's see. Oh, yeah. Now everybody can see. Everything else was grayed out. I don't know why they left that in the unlicensed edition. Okay, so a remote probe, and a local probe for that matter, is the agent installed on a device, a computer, that reports back to the core PRTG server, which is what you guys log into. A remote probe and a local probe, for all intents and purposes, are exactly the same thing. There is a key difference between them from a L7 standpoint. The local probe is what we use on the PRTG server to monitor firewalls and routers. It is a remote probe. It's just installed on the PRTG server. Everything else, again, is still a remote probe, but it's used to monitor stuff at the customer site. A group is basically a defined set of devices. You can drop a bunch of devices into a single group. When we get into what our standards are, essentially a group is going to be exactly the name of the customer as it appears in ConnectWise. A device is a network object that we're going to be monitoring. A sensor is a method or the way that we're monitoring, whether that's SNMP, SSH, for disk space usage, ping. You know, there's a million different types of sensors in PRTG, and they're adding them all the time. And a channel is kind of a subset of a sensor. It's basically what that sensor is monitoring. So is it for a ping sensor, is it monitoring latency, jitter, up and down? If it's a data store monitor or a data store sensor, it's monitoring total space, free space, maybe disk usage. So a bunch of different things can come into play there. To be honest, for the most part, what we care about is up-down on any of our routers and firewalls. when we're not doing performance troubleshooting. When we're doing performance troubleshooting, then what you'll notice is within every SNMP traffic is it actually monitors the total usage over the circuit. All right. So our basic standards, I think actually we just went over this. For edge network devices, we're monitoring the ISP or the client's router if they own their own router, both primary and backup, definitely the client's firewall. And from the outside, that's basically where we stop. There's ways to get internal from the outside, but at that point it doesn't make any sense. As a primary, we always use the SNMP traffic sensor. That gives us much more data than a ping sensor. Ping is up, down, and latency. SNMP traffic gives us up, down, latency, total bandwidth usage, and that's really where it becomes much more useful than the ping sensor. The ping sensor we just talked about. The way that every ping sensor, and when we go over the deployment documentation, should be set up is not to send one ping at a time. It should be set up to send a group of pings and report back only when a certain % of those have failed. You'll get way too many failures based on ping sensors if they're not set up right. ESXi servers, actually I need to take this part out. We're not monitoring ESXi with ping sensors. There's a really technical reason for that, and I'm not going to get into it. Host hardware, basically it looks for failure flags produced by the ESX server, whether that's a power supply, a disk that dropped off, a RAM chip that's bad. It reports back any of those things. They have a certain standard. They do it based on something called a flag, which comes back as a number, but that's a standard thing, so they know, based on this number, this is what's failed. Host performance, we're not going to have any alerts based on that, but it's a way for us to keep historical data on performance usage on these free servers, which, the internal ESXi monitoring only goes back an hour. Data store free space, this basically monitors for free space on the data store. One of the things we can't see from lab tech is the host. One of the more critical pieces that you run into is running out of disk space on the data store. Luckily, I don't think it's ever bitten us, but it's to where we've had like a huge or major corruption, but we've had a lot of times where somebody's randomly logged into a server and only seen 5 or 6 gigs left. So it's gotten pretty close. Right now? Yeah. So with the data store free space, primarily the reason for monitoring it is because VMware has enabled something called thin provisioning. That allows you to over-provision or assign more than the actual amount of hard drive space you have. And because of that, when you've assigned it, that means all the guests believe it's there and will use it. So if somebody tries to, do a Shadow Protect GRE and they drop, 200 gigs of EDB files on a server that we've over-provisioned, it can quickly run that data store out of free space. If you do that, every machine based on that data store is at potential for corruption and probably will be corrupted, and that's why we need to monitor the percentage of free space on a data store. Documentation. So here's where I'm going to drop out of our PowerPoint and go over to our Confluence page. What's that? Yeah. That's only because I've clicked those links before. Let's see if I can show everybody my password. So while we're waiting for this to log in, first thing we're going to go through the shorter stuff first, the newest stuff, because everybody here is relatively familiar with the edge network monitoring, which we're going to come back to. The new stuff, which is the ESXi monitoring, nobody has any clue about, so that's why we're going to go over it first. It's in there, the checkbox, yeah. So actually, PRTG is probably, we'll go over our server configuration of that, not how we deploy it, but how it's installed on our server. So PRTG is installed on L7, L7H, PRTG01. It has a DNS name externally of prtg.l7.com. Everybody gets their own username and password. Nobody should be sharing each other's username and password. Some customers have it. There's our license key. If we have a customer that duplicates our IP range, it's a very difficult method. Currently, the only way to monitor their internal network after that is using a remote probe that reports back. There's really no way for us to externally monitor something that duplicates one of our IP ranges. If they have their own MPLS, such as LaVie, NMS, trying to think of LASIK, we don't monitor from PRTG directly to every site because MPLS is all private. We can only create a VPN tunnel to their firewall and then use their firewall for routing into their network. So keep that in mind if you're talking about somebody who has, a few dozen routers. The likelihood that we're monitoring that directly is pretty unlikely. So doing something like trying to ping that router from your desktop here is not going to be a good idea. You want to be on the PRTG server where we have an active connection to their network in order to do those tests. Right. So yeah. So when you see an entire company go offline at once, there's two reasons: either the whole the corporate office is down, or our VPN, the central router or firewall is down, or our VPN link is down. Generally, it's our VPN link. Okay. PRTG.l7.com is what you would RDP into. PRTG01 if you're in LabTech trying to get over to it. So that being said, let's see if I can find remote probe ESXi. So setting up a remote probe and sensor-free ESXi. So this is a new thing that nobody's familiar with, which is why I'm going over it now. Ignore that warning. That's going to go away soon. What do we do here? We are setting up a remote probe at the customer's network. We have chosen the network probe server to be always the recipient of that remote probe, the network probe being a LabTech concept, not a PRTG concept. What does it require? It requires .NET 4.0 to be installed. Last week we added that to the automatic push for patching, so that should be installed on any server you do it. When you go to work on a remote probe to add a VMware sensor, if the VMware sensors are all grayed out, it's because it doesn't have .NET 4.0 installed on it. To do our data store-based sensor, SSH needs to be enabled on the host. That's how it gets in there and is able to see the data store. There's a guide in here how to enable SSH in ESX5X. It's pretty similar in 4. Anytime you enable SSH in ESX, it creates an alert status, which is pretty annoying because then you don't see that there's another alert. So in that guide is also how to suppress the warning. Tony? The remote probe just needs to be a local OS at that site. We've chosen the network probe to be that so that we have a standard. Every site in LabTech that has a server should have a network probe. Then, of course, the prerequisite is that a network probe is on there. That's more a policy-based requirement than it is a actual technical requirement. So I'm going to try, and I'm not going to breeze through this, but rather than reading it to you, I'm just going to give you kind of the high points. Everybody here is going to do some of these. When we go to do the deployment, there's just far too many to have one guy do it. He'll spend the next 2 months. So make sure when you're reading through this, again, just like I said before, you need to stay very close to exactly what it's saying. Don't, kind of have your eyes go fuzzy while you're going through this and just try and hit all the bold letters. That's not going to work. It's a very intricate process. It's not complicated, but it's intricate. You want to make sure you do it exactly right, in the right order. You start getting out of order, things start going wrong very quickly. So the first thing to do here is to make sure you have all your prerequisites done. So installing .NET 4.0, everybody should know how to go to download.microsoft.com and install it if it's not. You can also re-push it through LabTech. I'm not going to go over how to do that. First thing you're going to do is push the script here called install PRTG network probe. That downloads the PRTG installer, installs it, applies our specific configuration settings to that PRTG probe, and then the PRTG probe itself, or the remote probe, checks in. Hi, can I help you? Okay. Yep. We're great. Thank you. You will want to be careful. It does take its sweet time checking in. Sometimes it will be very fast, but I have had one that is that took probably 20 minutes to check in. Right as I thought there was going to be something wrong, I hit refresh on the PRTG page, and it showed up. And by showing up, if you look at my screenshot I have here, basically you're going to get this picture where it says, there's your probe name, approve or deny. Yesterday, Matt and I did an installation. Something went wrong during the installation, and it shot a ticket over to support@l7.com. Eileen accidentally auto-closed it. She knows not to do that now, but it does report back if there's any issues. I guess it does a secondary update process, and that update process failed. Literally all we did was get on the machine and rerun the installer manually, and it fixed it instantly. Okay, so once it checks in, which again is at 15 minutes or so, you're going to go to the group view so you can actually see these things, and then hit approve new probe. From there, now we're going to set up basically what is an auto discovery group. Actually, the first thing we're going to do is clean up the probe device itself. Whenever this first installs, there's actually 3 or 4 other sensors out here that we don't need. All we're going to need is probe health and system health. To be honest, you can't delete these, so that's why we have them. You can delete all the others. From there, we're going to create an auto discovery group. At the bottom of PRTG, you get a button that says auto discovery group. You'll see that. You're going to choose the proper remote probe to install that auto discovery group on. You're going to make sure you name the group exactly as it appears in ConnectWise. Just like the local probe installation for firewalls, it has to be exactly as it appears in ConnectWise so that it generates a ticket under their customer. If it doesn't, if there's one letter off, one space off, it's not going to work. So you need to make sure it's exactly. Again, attention to detail, making sure things are going to work right. As you're adding these, after you change the group name, on the next page, you're basically going to set this automatic creation using a device template. We've created an L7 VMware template as one of the templates that it has with the settings that we need. If we look here, you can't see it on this screen, but it shows a couple lines up from here. Basically, check that box. Moving down the list, you're going to just basically choose all the settings that this says. We want to use DNS to resolve names. If they have the ESX servers in their DNS, it'll put their name in there. If they don't, it'll put their IP address. I would like for you, if you see the IP address in there, to go back and add the entry in their DNS based on our naming convention. And then you're going to have to manually change it on here, because unless we do a rediscovery, which will be another week, it's not going to show up. So at the end of that process, basically you're going to continue through, and it's going to start the auto discovery process and pick up everything in the IP address range that we specify up here, and add it to PRTG. If you remember, I said that we're monitoring ping for ESX servers, and then I said no, we're not. The reason for that is if I monitor ping for ESX servers, PRTG will monitor ping for anything that shows up during that auto discovery scan. There's no way to say just add ESX servers. It adds every device it finds on the network, and if you have a sensor that works for it, it will add the sensor. So we remove the ping sensor from the ESX monitoring because it will ping everything on their network with a sensor, and we don't want to do that. I don't care about somebody's workstation that goes up or down. Unfortunately, they don't have the ability to say, ESX template, but also don't add anything else that shows up. Then there's a little bit of cleanup. Every ESX version is different. This is unfortunately not a 100% perfect solution. It does pick up things that we don't need. Matt and I did an ESXi 4.1 yesterday. For some reason, it decided that there were 3 data stores on there called Hypervisor 1, 2, and 3 that didn't actually exist. It added them to the set of sensors that were installed. We don't need those. They don't, like it said that there was a 10 megabyte data store on there. Clearly that's not the right one. It did add the proper data store, which we kept, but there is always going to be, there's probably going to be some level of cleanup you have to do whenever you're looking at the results of the auto discovery process. The things you don't need to clean up, which I don't think is in here, is all the additional devices besides the ESX servers. You want to leave those, because when this auto discovery process runs every week, it's just going to simply re-add them. If you delete them, you're wasting your time. It's going to re-add them. No sensors are going to be created, but they will show up as a device. Additional things, talk about the DNS stuff in here. How to fix it. There's a link here to our standard network device creation or naming convention. Make sure you're following that if you have to go back and rename something. Looks like somebody added something here as well, if you need to change the name in it. Anybody have any questions about this process from a high level? So at some point, either probably Monday or Tuesday of next week, of course, when I'm not here, you guys will probably get a list of people to install it on. It'll probably revolve around who your customers are as a SME, and you'll go from there. So everybody will have a chance to experience installing this. Yes? Actually, CAN needs to be redone. So you'll be, right. Okay. So that's the ESX host monitoring. Did you have a question? Okay. Setting up a new customer site and sensor and PRTG. This is the external firewall monitoring, router monitoring. Again, you have to be very close to detail on doing these. They need to be set up exactly. You know, if there's a bracket there, make sure you put a bracket. Make sure you follow it exactly. I can't say that enough. This is the guide on how to set up a new customer under our local probe now for doing firewall and router monitoring. Our project engineers do this every single day, almost every time they do a ramp up. Hopefully our guys installing firewalls are doing this every time they're installing a firewall. Anytime something on the edge network at a customer changes, there's something on here that probably needs a change as well, so we're monitoring the proper things. For those of you guys who have done this a million times, if you tune out, just want you to be aware of the one thing that's probably the most important, which there's a checkbox when you add a new sensor to not ignore or to alert on disconnected interfaces. We weren't aware that this was there, and we assumed that a disconnected interface was going to show down. Basically, when you go to add an SNMP traffic sensor, when you hit add, you check all your boxes for the interfaces you want to bring up. And I'm only showing this for the guys that are probably going to glaze over and start eating their sandwiches. You need to make sure you change this from ignore to show alarm when disconnected. If that is not changed, we'll know when the WAN goes down if it's disconnected because the whole thing is going to be down. But any other interfaces that we're monitoring, we're not going to know it's down. We're just going to see traffic go to 0. Like somebody unplugs it, or the switch dies, or the power dies on, you know, the backup modem. You're not going to see that unless this option is chosen. We implemented this on all the existing sensors yesterday. We probably had about 5 or 10 that showed up. At this time, we're not monitoring any switches. But yes, I completely agree. %. You do not want to set this on any switch at all. If we ever end up monitoring switches, we actually do monitor 2 switches at our data center. I did accidentally enable this for those switches, and it immediately showed a whole screen of red. So it's correct. Yeah, there was actually, I don't even know, Levy somehow was already set up like this and must have been part of our setup document. Nobody else was, which explains why we've probably never seen a LAN interface go down ever for a managed service customer. So this needs to be updated to stats because it's not stats anymore. It's prtg.l7.com. Expect that to be updated. You will see that we need to create a group. Remember now that we are no longer monitoring everybody at all times and alerting on that. Now there's a deviation between people with 24/7 support and people with 8x5. So you want to make sure you're in the right subgroup of 24/7 or 8x5. That doesn't change the monitoring, but it changes, remember, the alerting. The dude who's on call getting a phone call at 3 o'clock in the morning is not going to appreciate it if you put a basic support contract under the premium support group. So make sure any accidents you make are today and never again. So going through here, I'm going to hit on the high points because we only have an hour, and for me to basically read this to you doesn't make a whole lot of sense. You know, basically you're going to create the group again. You're going to make sure it's named exactly like it is in ConnectWise. That is critically important for making sure the ticket is created under the same person. You can see this person's created one for Dolphin Components Corporation. That is exactly the same name as it shows up in ConnectWise. Moving right along, after you create the customer, you're going to add the device. The device is going to be their ISP's router or their firewall, or both, probably both. And then you'll see in here a very specific naming convention. Site, which is our city-state, ISP/circuit type, firewall/router model. There actually should probably be 2 examples in here since the example we gave is kind of a special one. But the example here says Delray, Florida. The provider is STS. The type of connection is a T1. This device is what we call customer premise equipment, or the router from the ISP. For something like a firewall, it would say WatchGuard XTM23. Again, remember, sometimes customers can get into this. You want to make sure it's typed out professionally. You're using proper spacing. You know, type it the way that the manufacturer types their name. You know, don't type Cisco, CYSCO. You know, use professional standards. Don't even start, like, I've seen that before, so don't. Whenever we do monitoring, we're currently only using IPv4, so as you're coming down that setup page, essentially you put in the IP address of what you've enabled for SNMP or ping monitoring in this portion. The tags or the icons? Yeah, so there's a router, which is a default. If you're feeling a little froggy and you know you're monitoring a firewall, go ahead and click that little brick wall of fire on top. Makes everybody feel a little cooler. Moving down the list, the location field, you'll want to make sure you start with the address, the phone number, and the hours of operations, and then the circuit information for contacting support. If you start with anything else, the maps, not that it's a terribly useful thing, but the map setting doesn't work at all, so we always start the location with the actual address. Please make sure you put this stuff in there. This is required. This is critical for the on-call people. You don't fill this out, people on call are going to be pissed at you, and they will find you, and they will hurt you. Yes, that's exactly what I'm saying. Yes, if you put the address first, you can leave the phone. I think you can leave the phone number without a double line break, and it doesn't make a difference. The problem we had initially is everybody was putting the circuit information at the top, and that was breaking all the map functions. Yeah, so you want to make sure the location is at the top. And again, you can see this person did an awesome job on their naming convention and followed it exactly. Whoever created this document, probably Chris. Next, we're going to choose our sensor type. Again, you're going to be in a wizard, so this is going to look a lot different. SNMP traffic wherever possible. If you can get an ISP to turn SNMP on their router for us, do it. They're probably not. And then you'll have to fail over to doing just a ping. If it's a firewall we manage, of course, you should be enabling SNMP. There are some guides and Confluence on how to enable SNMP on different devices out there. Good. So ping. Here's the naming convention for ping. Make sure you follow it exactly. Don't want to put SNMP dash or something weird dash. It needs to be ping dash. That lets everybody immediately know this is a simple ping sensor and that's down. That's it. You need to make sure it says ping for these. WAN/T1. Now I know if I'm blurry-eyed at 2 o'clock in the morning, I know it's a WAN if they're T1. This is especially important if they have multiple interfaces where people tend to have a T1 and a Comcast. This lets you quickly identify that it's the T1 that's down and not the Comcast, because nobody's memorized this IP address when they are looking at it in the morning or at 2 o'clock in the morning. They're not going to recognize that IP address. Oh, by the way, that's Asmus, Shrebnick, and Kaufman's T1, not their Comcast modem. You know, that is the T1 in there is important. And then the IP information, and that is for troubleshooting, because the first thing I'm going to do is log into PRTG and probably try and ping that thing and make sure it's actually down. A double check on making sure. And then I'm probably going to ping the gateway information, and that's the reason why the gateway is there. So now I'll know if it's down, and if the first hop after that is down, that lets me know if it's an ISP problem or a device problem. So moving right along. Settings tab, uncheck to inherit. Okay, so this next session is talking about dependencies for master and child sensors. This is based around the concept that I don't want to know, I monitor your WAN 1, your WAN 2, and your LAN. I don't want to know that all of those are down when your WAN 1, which is the only thing I'm monitoring through, goes down. Because what PRTG will do, if you don't set this up properly, if WAN 1 goes down, of course now it can't monitor LAN 1 or WAN 2. It's going to send alerts about all of them. So now I'll have 3 tickets to deal with. And you'll get woken up 3 times in the middle of the night instead of 1, because Apple Tree is going to get 3 emails, and they're going to call you 3 times. I promise you they're not going to call you and say, we got 3 alerts. They're going to call you 3 times, because they dispatch the way we do on ticket base. So what does this talk about? This talks about setting the master object or a dependent object for a particular sensor. If we're monitoring through the WAN 1, we're going to set that one as the master, and the other ones will pause based on WAN 1 being down. So you'll want to read through that very carefully when you go to do that. It's basically a checkbox, making sure you have the right one. SNMP sensor. So very similar to the ping sensor, but a little bit more nuanced. Whenever we have SNMP, now we want to add in what interface we're monitoring, because a lot of times we'll be monitoring multiple interfaces. So for a watch guard, they name their interfaces E0, 1, 2, 3, 4, 5, 6. So we match the way that the manufacturer tags their port. We don't use just a number. So like a Cisco will be, F00 or S000, whatever, 0/0/0, whatever the manufacturer actually tags their port, so that when you log into the machine or into the device, now you can actually have something that refers to it. If you type 1, there may be an S0/1, there may be an F0/1 when you log into something. That doesn't give the person troubleshooting it enough information, so we have to be very specific. So from their alert, now they can log into the device and see the actual port name. WAN or LAN, so if it's a WAN sensor, you're going to type WAN. If it's a LAN sensor, you're going to type LAN. That way we know if it's the internal or the external. Pretty straightforward. I have no idea what you're talking about. We had the 4 outages yesterday at once because we enabled interface outages, so interface disconnects to create an alert. It's probably we had never had the right one, because we didn't know that it was wrong, because we never had an alert that a disconnected interface was a problem. So again, just like the ping monitors, we want to set up dependencies and master-child relationships with these. We don't want multiple tickets if we don't need them. One key thing to think about when you're creating these. So generally, we're able to ping the ISP's router, and we are able to SNMP our firewall. When you go to set up these dependencies, I don't want to know that my firewall is down if their router is down, right? So you're going to want to set up the dependency on the primary interface on the firewall to be dependent on the primary interface on the router, because I don't want to get, now 2 tickets, one for the firewall and one for the router when the router goes down. When you're troubleshooting these things at 2 o'clock in the morning, it's nice to have everything. That's what all the pre-work is for. It's to make, the critical outage happen like that. There's no guesswork. It's straightforward. The router is down. I don't have to worry about the firewall being bad. That's why we stopped monitoring just firewalls, because if we monitor just firewall, now I don't know if somebody unplugged the firewall or if the ISP went down or if somebody got in there and made a bad configuration. I would work on the outage and then go back and fix it at the end of your ticket. Now, the thing to remember as you're talking about that, remember there's think of it like a house. We monitor through the doors of the house. With PRTG, you can only monitor from one door at a time. So we can't monitor both the backup and the WAN from the same door. When we create a device in PRTG, it's by one IP address. So if I monitor through the primary and the backup goes down, I will see that the backup goes down. But if I monitor through the primary and the primary goes down, I will have no idea what the backup is doing, because now my door is closed, essentially, right? So I can't see the backup once the primary goes down, which is why we pause the backup, because we have no clue. For somebody like Levi that Matt works on all the time, when those primaries go down, the first thing he does is get into PRTG and try and telnet over to the backup, because it's our way in. But that's a key point to remember. Backdoor. That's why it's a backup. Okay. For information on setup SNMP, there's other documents in this section. I guess we could have just referred that. I'll give that a like. All right, backing out of this. Let me look at my PowerPoint. There was a couple other things. Remote probe, device sensor, server configuration we went over. The main PRTG page in Confluence is basically under guides internal. It's becoming kind of our de facto repository for how-tos and standards on technical issues. There's a document on how to create a remote probe. It's a rehash of what's in ESXi. This just goes into more detail for how to create the stuff on ESXi. This is if you need something like the Sedano's remote probe. They match our IP subnet, so we can't monitor them directly from the data center. We have to use a remote probe that just sends us the data. So unusual stuff, stick to standards. You guys have to be very close every time, very precise, very accurate on every time you do these. Take the extra time. There's no rush in getting through setting up your sensors correct. I would much prefer you spend double the time now than double the time during the outage. Stick to standards, stick to standards, stick to standards. In the future. Yes, Chris. Yeah, so that's great. So Chris is saying, for all the people watching the video and listening on the phone, if you go to set something up and you don't have that information, use question marks for a placeholder so that somebody knows that you knew that, but we don't have that information. And that way, you're not just a grumpy person and you're like, oh, this guy did it all wrong. I got to go talk to them and tell them why. If you see the question marks, now you know that somebody's probably working on it. They just don't have that information yet. Chris and the project team uses that a lot because we'll start monitoring immediately, but the customer generally barely knows what their information is, who even their ISP is. So, but we prioritize getting the monitor up and running before we get the information about it. So the customer has no ability to change ISP on their own because they have no access to their firewall. So if they did it, that would be impossible. What I would say is if somebody here changed it and you're not seeing the proper information, it's on the guy who changed it and didn't update the proper information. That's it. So Forge and Ruben specifically changed over to Windstream, and the documentation wasn't updated. Whoever did the IP address configuration on the firewall or went out there on site didn't update the documentation. There's zero shot they got in there and did it themselves. So the future help desk, just like anything else. So the future PRTG, as we advance in L7, we we want to get more technical, look at more information. Additional device monitoring, I left that very vague. Justin is working on doing additional device monitoring for FortiGates, which may be a new standard for, at least for FortiGates, with their own MIBs, because we are deploying them at photobar with high availability. One of the things we need to know is if it's failed over, if one of those devices is down. When you have something like high availability on the FortiGates, and you monitor that from the outside world, and you don't know that it's a FortiGate, you just see it up. You don't know that one of the devices actually failed. So it's kind of like a RAID volume, and you're in Windows and you're copying disk or files to it. You don't know that one hard drive is dead. You need to have that customized specific information. So Justin's working on something like that. In the future, hopefully we'll be able to monitor things like NASs, printers. It seems like we'll get a lot of tickets, but it's a way for us to get out in front of customer issues and hopefully fix them, hopefully via some automated script. Damon reboots NASs once a month. It would be great for him to know how long a NAS has been up so he can get an automated alert based on that and possibly create scripts based on those automated alerts so he doesn't have to get in there and reboot it manually or wait for backups to go down, before he deals with it. So that's the future. I think that's our entire presentation. Are there any questions? So Tony asked if we're going to be monitoring servers directly with PRTG. For Windows OS level, no. That's what LabTech is designed to do. For hypervisor level, that's not Hyper-V. So Windows OS level, that's what the remote probe is designed to do. We only have a couple Zen servers out there, and I think that currently it's only at BBX. So we still need to kind of make a standard on Zen server for BBX, but so PRTG has, just like with ESX, it has its own Zen server sensors, yeah. Yeah, we're on 13.7. Anybody else? Anybody from Ocala? Everybody's hungry. All right, guys. Have a good 10 minutes for the rest of your lunch break. I'll be posting this to Confluence